Merging with simulator in 3, 2, 1.
Hello and welcome once again. I'm your host, Ms. D. I'm here to talk about some shield metal arc welding today, SMAW. All right, here we go. Well, if we could go. If it wants to go, possibly. Okay, so we got a lot of objectives ahead of us. After we go through this, you should be able to work safely if you don't already do that. Understand striking the arc strike, characteristics of a good and a bad weld, and characteristics of a weld with too much heat or too little heat, and what it's supposed to look like. Arc length, work and travel angle, weld bead manipulation, position of the weldments, F numbers, stringer beads. So stick with me, guys. This looks just going to have a couple of parts, so I don't want this to get too long, okay? All right, here we go. So let's get started. Shield metal arc welding, or stick welding as it's better known, is used to join plate, pipe, and is commonly used for structural welding like buildings. SMAW provides a high temperature arc that allows for the weld pool to build up quickly. Okay? And then filler metal from the electrode adds strength and reinforcement to the weld that's been made. So usually SMAW is used on most types of metal from about an 1/8 inch to around 3 inches, but it doesn't mean that it can't go thicker or thinner. Okay, so SMAW requires little equipment, and the cost to purchase a machine is pretty inexpensive when you take things into consideration. So welds can be made on just about anything, okay? In order to become a skilled welder, you need to practice. Practice is required. I used to teach some deaf students, and my name sign was actually practice, okay? So I always tell people you need to practice. But here's the thing, you need to be critical of the welds that you make, okay? When you're developing your technique, okay, you need to make sure you're doing something good, and then critiquing what you're doing and making those changes in order for you to get better. Okie dokie, so when you first start welding, you need to set your machine up. So regardless if you use this machine the day before, you want to set it up. Always use a piece of scrap metal that's about the same thickness as your intended material. And then you can run a bead and change the settings as needed for your weld, so that when you strike that arc on your plate, it's going to be right. Okie dokie, so in order for you to weld, you must be able to strike an arc, okay? Now there are two different methods of striking an arc. One's called scratch. This is like a match on the side of a material. We're going to scratch it, okay? And the other is tapping. And tapping the electrode to start in the area you'd like to weld. This can be a little bit more challenging, especially to a new welder, because when we tap, you can get stuck. So the other thing is called arc strike. Arc strike is where the welder strikes the arc, but not in the area where the weld is not made, okay? So if we see here, here's our nice little pretty weld, and here's our arc strike. Now, if an arc struck in the wrong place, it can actually cause defects in the base metal. So this is one of my big pet peeves as a welding inspector. All arc strikes should be ground out, as it is considered a defect, and it can be means for rejecting the weld or even failing a welding test. So this is really important to make sure that you know and are accurately striking an arc. So what characteristics or variables make a good weld? Well, we need to think about it. So the first thing is proper amperage. Okay, amperage is relational to my heat. So as a welder, you need to be able to determine if the weld is too hot or too cold, ultimately requiring the welder to change the amperage as necessary. Now, the proper arc length. Well, what is arc length? Arc length is how far away the rod is from your weldment, okay? If you have an arc length that's too far away, you can create spatter, and you're going to have a really inconsistent weld. And too close to an arc length, and you might have stick out and improper penetration. Okay, so the rule of thumb is we want in arc length the same diameter as our rod. Industry standard is an 1/8 inch diameter rod, so I would like to have an 1/8 inch arc length. Okay, the next one is angle. We need to have a good angle, right? An incorrect angle can make an incorrect weld. You know, so we need to make sure that we have the proper angle, having the proper travel speed. And the last is proper manipulation. So all of these things are going to be discussed in more detail and understand how to make a good weld. Okay, so here's my proper amperage. Selecting the proper amperage is important to getting a strong weld, right? Too little amperage, the weld is going to be too cold, and it can look like it's sitting on top of the metal, okay? Too much, the weld is way too hot. The weld bead is very flat and almost buried into the base metal, okay? The weld bead doesn't have round beads, but more elongated, arrow-like, okay? And it kind of points. So if the amperage or the heat settings are incorrect, it makes it impossible to have a good weld. When having the amperage too low, there's poor fusion, poor arc stability, and poor penetration. On the other hand, the arc may be difficult to strike, or the electrode may even stick to the plate. So how do you tell whether the current or the amperage is too low? Okay, well, the weld will seem really thin and it'll look kind of like an earthworm. So let me show you some pictures. So we can see here, let me see. So amperage too low. Here it is, right here. Let me see if I can zoom in for you guys to see. See that? See how thin it is? Okay, here's too high, here's too long, here's too short, here's too fast. Okay, all right. Now, what happens if the current's too high? Well, the weld bead will look very, very flat and wide and sometimes kind of sunken in. When the amperage is too high, there can also be a lot more spatter. Having the amperage too high creates more heat, which can create undercut, or they look like little sharp bites along the edges of the weld. An undercut is caused when the arc gouges into the base metal and there's no filler metal being placed there. When it's too hot, there's not enough filler metal is placed because it's spreading out or it's burning away. So one of the ways I like to tell if the weld is too hot is it looks like it's running away. The ripples of the bead start to look like an arrow and they start to point towards the end of the weld. Now this shows that the amperage may have been just too hot and the welder is trying to compensate by moving faster. Okay, so if we look here, let's see if I can zoom in here for you guys. So too low, too high. Can you see there's like little arrows here? And if we look at the profile here, it's just kind of sitting on top. And if we can see, let's see, this is too low. See how if it's too low, it's just going to sit right on top. Now this would be something that's a decent bead. See how it's kind of very smooth on the cross section? And it's overall even, okay? When we look at some of the other things like too high or too fast, we can see that it's very irregular, okay? Okie dokie. So remember, do not make any current changes during welding because it can actually make arcing inside the machine and damage it. Just as an FYI. Okay, so how do I find an amperage range to start from? Well, maybe you start a new job and they give you an electrode that you're not really familiar with, okay? The industry standard for electrodes are 1/8 of an inch. So we're going to use this for example, okay? So take the diameter of the electrode. So we're saying it's an 1/8 inch diameter electrode, okay? And remember, when we refer to diameter, we're referring to the core wire. This doesn't include the flux, okay? Now we're going to take that fraction and we're going to make it into a decimal, okay? So 1/8 inch diameter electrode, and we're going to make this into a decimal. So 8 into 1, okay, is 0.125. You can do this on the calculator, but you can also do it longhand, okay? So after you find the decimal equivalent, which is 0.125, we're going to drop the decimal off, okay, so that you have 125. Now, this is a ballpark range for an 1/8 inch rod. So this doesn't mean that you don't have any adjusting to do, but it kind of gives you an idea where to start. Oh boy, arc length. So arc length is the distance from the end of the electrode to the workpiece. So we can see right here from the end of the electrode to your workpiece. All right, so this is, this is truly representing your arc length. So if your arc is too close, you'll smother the arc, or it'll even go out. If it's too long, you have a chance to create spatter and oxidization. So how do you determine arc length? Well, arc length is determined by the size or diameter of the electrode. So, of course, we talked about it, industry standard is 1/8 inch diameter electrode. So the arc length should be, let me hear y'all, 1/8 inch, woo, right? All right, pretty simple. So, but in order to maintain a constant arc length, the electrode must be lowered continuously while we weld because it's being burnt off. This is one of the biggest challenges when learning how to weld with stick, okay? It's remembering that it's being burnt off. Okay, so a weld that's made with a short arc, it's going to be really, really narrow and has lots of buildup. You might also have a hard time sticking, that type of thing, or the arc will have a hard time striking. When the arc length is too long, there's more spatter. Why? Well, because the arc's not focused on the weld pool. It kind of like flows out, okay? And the filler metal begins to spatter. So if you happen to make a weld with a long arc length, there's going to be spatter, and more likely the weld will be wide and not very tall or not have very much buildup. Okay, now there's a lot of different ways to describe work angle and travel angle. And I'm going to try to put them in a simple term for you to remember, as sometimes it can get kind of confusing. So, work angle, okay? This more or less refers to the position that you're welding in, like flat, horizontal, vertical, and overhead. When we talk about travel angle, it refers to the angle in which you're moving, whether the electrode is facing the end of the weld or the beginning of the weld, okay? When we drag or pull the electrode, we're using a trailing angle. When the electrode is more or less up and down, this is perpendicular. So, perpendicular, okay? When the electrode is facing away from the end of the weld, what this is called leading or pushing. Ultimately, when we weld with stick, we want to have mostly a trailing angle. And there's also this thing that says, when there's slag, we drag. This would be a drag. Okay, so there are many different types of electrodes. And when we work with some of the most common electrodes, a welder needs to just understand how to use them. So an E6010 is part of the fast freeze group. E6010 electrodes require what's called a whip. Okay, so what they're talking about as a whip is back and forth, back and forth, back and forth. So when the arc is struck, and in order for the gas to expand and the electrode to do its part by helping remove contaminants or impurities, the arc will dig in. And once it fills, the arc is moved back and forth. Okay? So using an electrode incorrectly could lead to failure of the weld because slag has actually been trapped into the weld. Okay? So we need to remember that and remember the motions that you're using. So the other common electrode is E7018. This electrode is part of the fill freeze group. Using a push angle with this type of electrode could lead to slag inclusion. Okay, meaning we can get slag inside it. Okay, we don't want to do that. So, but we can use a manipulation. Manipulation of the electrode can be really, really helpful, especially when we weld in certain situations like horizontal or vertical. So most of the time, it's more or less up to the welder, but remember that in order to avoid slag inclusion, it's important not to make any loops or circles that could trap slag. So the figure 8 here, the circular or the square, I personally don't recommend them, these types of things, because they're making a type of loop. Now we can use these in other situations, but we want to remember this probably isn't the best for stick electrodes. All right, so let's talk about some terminology. So as an inspector, there are certain things that are not allowed in structural welding. So I want to be able to clarify some terms. Some people kind of use them back and forth, and it can be kind of confusing. So the above movement of the electrode, this movement here, this is called a manipulation. Manipulation of the electrode is allowed when welding on structural material. In certain respects, we have to move it to get it where we're wanting it to go. What's not allowed is called weaving. Now, what's weaving? Weaving is where the welder takes and manipulates the electrode from one side of the joint all the way to the other. Now, this requires the welder to increase the amperage exponentially so that the weld pool will flow correctly. Okay? With this amperage increase, this increases the likelihood of issues happening with your base material. Ultimately, we are changing the molecular structure of the material. And when we're doing this, we could possibly be making it more brittle, which means it can break easier. So remember, when we're manipulating a rod, the manipulation should be kept as tight as possible, and the movement forward or upwards should be incremental and not too far. So I don't know if you guys can see this, but when I want to go really, really tight. Okay? I don't want to make big things like this, because then my puddle isn't coming with me and I'm having to kind of restart it.
Stay tuned for more videos. Please like and subscribe.
Weld the world.